So hello guys, welcome back to my channel. Today in today's session we're gonna solve some more problems of exercise 8.1. We already solved the first four problems of exercise 8.1, which is in my previous lecture. Okay, so you can check it out in on the button shown above. Okay, without losing in time, let's get started. Okay, so here question fifth question. Okay, so fifth question is what? That question number 5 is given that sec a is equals to 13 upon 12, find all the remaining trigonometric ratios. Okay, so here we have given one trigonometric ratio, the value of one trigonometric ratio, which is sec a is equals to 13 upon 12, and we have to find the other 5 trigonometric ratios, which is sine, cos, tan, cot, and cosec. Okay, so first of all, for finding the ratios, we first have to find all the values of the all three sides of a right angle triangle. Okay, so first of all, we must have to draw a right angle triangle here. Answer. So how we can do it? We just first of all draw a right angled triangle, right? So it is something like this. It is a right angle triangle, right? Okay, so here is our right angle triangle. Let me name it as A, B, and C. Okay, so guys, we have given that what we have given, sec A is equals to 13 upon 12. Okay, sec A is equals to 13 upon 12. Okay, so it is given in the problem. Okay, so what is sec A? We already know that sec A is equals to hypotenuse upon base, right? So sec A is nothing but hypotenuse upon base. So from this relation, from these two relations, we can easily find out that hypotenuse, sorry, we can easily tell that hypotenuse is equals to multiple of 13, right? Because here sec A is here the value of sec A is in fraction, and the numerator is 13, and here the numerator is hypotenuse, so we can write it as 13k, right? Where k is some multiple. Okay, so now the second one is base. Okay, so similarly we can also write base as a multiple of 12. Okay, so from the given information we find that hypotenuse is equals to 13k and base is equals to 12k. Okay, for what? For angle A. Okay, so for angle A, here the base becomes AB. Okay, so base is 12k, so it is 12k, and the hypotenuse is 13k. The hypotenuse in this triangle is our AC. Okay, so AC becomes 13k. Okay, so for finding all the all the remaining trigonometric ratios, we must have to find the third side of this triangle, right? So how can you find it? Yeah, very good. We can use Pythagoras theorem here. Pythagoras theorem. Okay, which gives us a relation between these three sides of a right angle triangle, which is as AC square is equals to AB square plus BC square. Okay, but wait, we have given here that hypotenuse, which is AC, and the base, which is AB. Okay, so we are given this two things, AC and AB, and we have to find BC. Okay, because the BC is our perpendicular, so we have to we just make this BC we just make this equation equals to BC square, okay, or equals to BC, whatever you like. So how can we do it? We just write BC square here, and the remaining quantity stands out to the other side. Okay, so here AC square is remains same, and this AB square is jumps to the second side of the equation, so it will be its sign will be changed. Okay, so here the sign is positive, there's nothing sign here, so we can assume that it is positive. And when he or we can see he or she AB square is jumps to the other side, then its sign will be changed. So here the AB square becomes minus AB square. Okay, so that's it. Now BC square is equals to what? We just put the values of the which we already find it here. AC is equals to 13k, so it is 13k square, 13k whole square, minus AB square, which is our 12k, so it is 12k square, and similarly we find BC square is equals to, what is the 13 square? 13 square is 169, and k square. Okay, यहाँ पे these two different quantities, okay, these are, so we just split these squares to each of the following. Okay, so 13 square into k square, which is 169 k square, minus, similarly here 12 square is 144, and k is an unknown quantity which is a variable, so we write it as k square. Okay, now what happens? Now we just take k square as common. Okay, k square as common. So here what we left with? Yes, 169 minus 144. We just what we have to do with it? We just have to subtract it. Okay, so 9 minus 4 is equals to 5, right? And 6 minus 4 is equals to 5. 6 minus 4 is 2, not 5. Okay, so it is 25k square. Oh, it's very easy, you know, because we already know that BC is equals to what? Under root 25k square. And we already know that 25 is a square of 5. So we can write it as 5 and k square. Okay, is become k. Okay, so we have already find our value for BC is 5k. So we can say that BC is, the value BC is a multiple of 5. Just write it here. So BC becomes 5k. Okay, now that we have all the three sides, we can easily find all the trigonometric ratios. So first of all we write sine. Okay, sine A. So what is sine A? Sine A is perpendicular upon hypotenuse. So here the perpendicular is our BC, which is 5k, and our hypotenuse is AC, which is 13k. So you can write it as 5k upon 13k. Here the k will be cancelled out, and the remaining value will be 5 upon 13. Okay, so now the second one is our cos A. So we already know the formula for cos A, for the value of cos A. Okay, that cos A is equals to base upon hypotenuse. Here the base is AB, which is equals to 12k, so we just write 12k here, and the hypotenuse is similarly as sine A, which is 13k. So here the k will be cancelled out and the value becomes 12 upon 13. Simple. Okay. Now the third one. Okay. The third one is what? 10a. Very good. 10a. So we also know the value of 10a, which is 10a is equals to what? Perpendicular upon base. So the perpendicular is BC, which is 5k. So we just write it here 5k upon the base is equals to AB, which is 12k. So we just write here 12k. Here the k will be cancelled out and the remaining value is 5 upon 12. Very good. Now we have find the main three fundamental trigonometric ratios, and now we left with only two. Okay, three, basically three, but here we already have given one trigonometric ratio, so we just have to find two more. Okay, now we find cot. Okay, cot A. So we already know that cot A is equals to base upon perpendicular. So here the base is AB, okay, which is 12k. So you just write 12k here. Now we know that perpendicular for angle A is here BC. Okay, so BC, what is the value of BC here? Yes, BC, the value of BC is 5k, and similarly the k cancelled out and the value becomes 12 upon 5. Okay, now the last one, we left with cosec A. Okay, cosec A. We already know that cosec A is equals to hypotenuse upon perpendicular, because it is inverse of sine A, right? So here the hypotenuse is AC, right? So value of AC is 13k, so we just write 13k here, and the perpendicular is BC, which is 5k, so we just write 5k here. Now the k will be cancelled out and the remaining value is 13 by 5. Okay, that's great. Now our question is completed. Okay, so you just have to follow the three steps. See, three simple steps. Okay, what are the three steps here? Let me count for you. Okay, the first one is this one. In this step, we just have to understand what we have given. Okay, so here we have given that sec A is equals to 13 upon 12, right? And from this information we find hypotenuse and base. So it is the understanding of the given, what we have given. Okay, and the second thing is what we have to find is given here. Find all the trigonometric ratios. Okay, so for finding all the trigonometric ratios, what we have to do, okay, it is in the next step. So here the next steps becomes what we have to do. Okay, what we have to do to find the all trigonometric ratios. Okay, that's the question, and this step is basically depends on this what we have to do. Okay, so here we assume that we have to find the trigonometric ratios. Okay, so first of all we have okay, the first thing strike in our mind is, okay, so we have to find all the trigonometric ratios, so we have to find all the sides of right angle triangle. Yes, but we have given only two. Okay, so we have to find the one more side. So how can we find it? Yes, the theorem one struck in mind is Pythagoras theorem. We can use Pythagoras theorem to find the other side, because we have given already two sides. Okay, if we have given only one side, then we cannot use the Pythagoras theorem. Okay, so here we have given two sides, so we just apply Pythagoras theorem. Okay, it is the step two. Now the step 3. Okay, Now the step 3 is what? Okay, the step 3 is very important because whenever you write all the values, you just left with, and you just left the step 3. You just skip it. Okay, but it's not right. You have to write it all last, that what you have find. Okay, the step 3 is what you have find. Okay, what you have find. So you find it the remaining trigonometric ratio. So write it down here. Okay. Now move on to the next question. The question number 6. Okay. So here's the question number 6. Now we just follow our 3 steps. Okay. First, second, and third. Okay. Now we have given that if angle A and angle B are acute angles such that cos A is equals to cos B, then so that angle A is equals to angle B. Okay. So you are giving that two angles are acute angles such that cos A is equals to cos B, then so that angle A is equals to angle B. Okay. So for this, we just draw a triangle here so we can easily understand the question. In all, not all, but most of the questions of trigonometric is solved, is half solved when you draw a diagram of. Okay, some masters say that trigonometry is basically depends on the understanding of a question. Okay, if you understand the question correctly, then you can solve it easily. Okay, so here we have a right angle triangle. Okay, now we just named it A B C. Okay, because here, sorry, so it is not B. Here the B is acute angle, so we can name it like this, right? We can name it as like this. Okay, so here angle B is acute, right? Less than 90 degree, and angle B is also acute, which is less than 90 degree. Okay, now cos A is equals to cos B. Okay, we have given that. What we have given? We have given that two trigonometric ratios of different angle are same. Okay, so here okay, so here cos A is equals to cos B, right? Okay, so first of all, understand the diagram and the meaning of this. Okay, so what does it mean to you? Okay, what can you find from this given equation, or given equation that cos A is equals to cos B? What you have to find from it? Okay, we just have to understand the equation properly. Okay, so here the cos A is equals to cos B, then let me clarify here that cos theta is equals to base upon hypotenuse. Okay, base upon hypotenuse. Okay, but for which angle? For angle theta. So here the cos A, it means it will become that base upon hypotenuse for angle A. Okay, is equals to what? Base upon hypotenuse for angle, right, B. Okay, so here we have two different angles, so we have two different bases. Here the hypotenuse will be same, but the bases will be different. Okay, so what are the bases here? Okay, let me look at from the eye of this angle. Okay, from the eye of this angle, we have AC as a base. Okay, for A. Okay, so we just write here base for A is AC. Hypotenuse is AB. Is same for, okay, so AB. Right. Now base for B. Okay, for this angle. For this angle, the base is BC. Right. BC upon hypotenuse. Hypotenuse is AB. Same. Okay. Now this AB will be cancelled out easily, right? So we can cancel it out. What we are left with? We're left with AC is equals to BC. Okay. So here we find that AC is equals to BC. If these two sides are same. Okay. Then we know a theorem that said that the opposite angle of the same sides are equal. Okay, we just write it at from sorry from a theorem which says that opposite angles of equal sides are equal, right? So from this we can easily write that for this side the opposite angle is B. So for AC is equals to BC, we can easily write AC. Okay, so AC, यहाँ पे AC ये, this is AC. Okay, so the opposite angle for this AC will be B. So here the angle B is equals to what? Is equals to BC, opposite angle of BC. So here the BC is this, then opposite angle is A. So it is A. Okay, but remind me that what we have to find. We just have to find that angle A is equals to angle B, and we have find that angle B is equals to angle A. That means the same, okay? Because it is commutative. So it is angle A is equals to angle B. Either you can write this or we can write this. Both are same. Okay. So that's it for the question. Let's move on to the next question here. Okay. The question number 7. Okay. So what is the question number 7? So there is some printing mistake here. We just clarify it that it is not 7 comma 8, it is 7 divided by 8. Okay. Oh, that's it. Now answer, or we can say solution. Okay. So we have given that if cot theta is equals to 7 upon 8. Okay. So first of all, what we have given, we just write it as it is. Cot theta is equals to 7 upon 8. Okay. Now what we can understand from this sentence, cot theta is equals to 7 upon 8. Yes, we can easily now understand because we already done it in our last questions. Okay, so we can easily write it as we already know that cot theta is equals to what? Base upon perpendicular, right? Base upon perpendicular. So from these two relations we can easily write base is a multiple of 7, so we can write it as 7k. Now perpendicular is a multiple of 8 because the 8 and perpendicular both are in denominator, so you can write it as 8k, right? And we have given two sides. Okay, now we have given these two sides, but the main thing here, we have to find sine and sine, cos, cot. So we must have to find what? We just have to find the hypotenuse of this triangle. Okay, so let me draw a triangle. As I said, we have to draw triangle for each and every question in this exercise because it is must here. In the introduction or in application also, you must have to draw the triangle, okay, to understand the question properly. And if the diagram is correct, then you will definitely do the question if you practiced it. Okay, just name it as ABC, right? This is A, this is B, and this is C. Now let me name this angle as theta. Okay, that's it. So we have given that base upon perpendicular for angle theta. Okay, so for angle theta, base becomes this BC, which is equals to what? Which is equals to 7k. So it is equals to 7k. Now the perpendicular is 8k. Here it is AB is perpendicular, so we can write it as 8k. Now we have to find this hypotenuse. Okay, so what theorem we can use it? Use it. Yes, definitely. Now you can say it. If I ask you in sleep, then you can also tell me that there is no other theorem in trigonometry more useful than our very favorite and useful Pythagoras theorem, right? Very good. Pythagoras theorem. We're gonna use it. Pythagoras theorem. Okay. The Pythagoras theorem, what we have? AC square is equals to AB square plus BC square, right? We have this. Now, from this AC square, we have to find AC square. Okay, so we uh, write this equation as it is. Now, what is AB here? AB is 8k, so it is 8k ka whole square plus BC is 7k, so it is 7k ka whole square. Okay, now, but we have to find AC. Okay, so we just have to calculate this all. Okay, so AC square is equals to 8k square. So what is square of 8? 8 is a 64, right? 64k square plus 7 7 is a 49, which is 49k square, right? But now what we can do, we just add this. Okay, so here the 9 plus 4, it is 13. So 13 1 carry, and it is 11 1 1 3, right? And k square. That's strange, right? Okay, no problem. So here we have left with this 1 1 3 figure. Okay, so what we just do here, we just have to find AC, and but this 113 is not a perfect square, so we cannot find the square root of this. So we take this, that our method is wrong here. Okay, so we just do it other way. Okay, we just not use Pythagoras theorem here. So sorry Pythagoras, we don't use you in this question because it is something different. Okay, now the first one, what you have to find? 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta and 1 minus sin theta. Very good, sure. So we have 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta, right? This is we have. So for this, what you can write here, okay, we learn a theorem, not a theorem, but what can you say it, a shortcut, okay, sorry, identity, that a minus b into a plus b becomes a square minus b square. Okay, so similarly here the 1 is a, and let that 1 is a and sin theta is b, so here a plus b and a minus b, so it becomes a square minus b square. Similarly here, so we can write it as 1 square minus sine square theta. Okay, when you square an trigonometric ratio, then you have to write the square sign here on sine, not on the angle. Okay, because if you square the angle, then the angle will be changed, okay, and the angle will be maximized. So we cannot maximize the angle, we just squared the value of this particular trigonometric ratio, so we write the square sign on sine, okay, because we have to find sine theta and then square it, okay, not sine theta square, okay. So similarly here we can also write 1 square minus cos square theta, okay. But here we apply one more identity which we will study in our, I think, 6th or 7th lecture, that sin square theta plus cos square theta is equals to 1. Okay, so we can also write it as 1 minus sin square theta is equals to, yes, you're right, cos square theta, right? Similarly, 1 minus cos square theta is equals to, yes, sin square theta. Very good. Okay, so now we just write it as 1 square, which is 1 minus sin square theta. So we already know that 1 minus sin square theta is cos square theta. So we write it as cos square theta. Now upon 1 minus cos square theta, which is equals to sin square theta. So we write it here sin square theta, right? But we also know that cos theta upon sin theta is equals to cot theta, right? Okay, but first we just write it as cos theta upon sin theta whole square. Now we already know that cos upon sin, cos theta upon sin theta is cot theta whole square, okay, which is cot square theta. Okay, that's cot square theta. And we already know the value of cot theta, so here by putting the value of cot theta, which is 7 upon 8 whole square, is equals to 49 upon 64. Okay, similarly the second one is cot square theta, which is also equals to this first one. So similarly for second one, cot square theta is equals to 49 upon 64. Okay, so here the our second question, our seventh question is completed. Now we will discuss the next questions, which is 8, 9, 10 and 11 in our next session. So tab tak ke liye goodbye, see ya. Or if you like the video, then please hit the like button and subscribe to our channel for further assistance in trigonometry and the other 10+ topics. And if you have any doubt, any query, then please comment down below so I can read it and answer it in our next lecture. So bye bye, see ya.